Okay, we're continuing now with example 8, and we are looking at this problem, and notice that we have cosine here and sine here. It's going to be very important for us to put it in terms of 1. Now, if we study our double angle identities for cosine, we realize that there is a identity for cosine 2 theta as 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. So what we're going to do is we're going to do a substitution. 1 minus 2 sine squared theta plus 3 sine of x. This really is an x here in this case, right? Minus 2 is equal to 0. All right, let's clean this up here. Minus 2 sine squared x plus 3 sine x. That would be a minus 1 is equal to 0. Let's distribute a negative sign. Clean it up here, okay? All right, so can we factor? I forgot my 2 here. Okay, it would be 2 sine x and then sine x, right? We have 2 factors here, here. Now, we know we have 1 at the end, but we got a minus 3. Oh, wait a minute, that was a minus, that would be plus, okay? So the last sign is positive. Both of them are going to be that sign right there. So it's going to be a minus and a minus. All right. Well, here we have sine of x is equal to 1. We know that's pi over 2. And here we have, again, sine x is equal to 1/2, okay? It should be becoming kind of clear here. Pi over 6 and 5 pi over 6. So these are our 3 different answers for that one problem, problem number 8. I hope that helped you. All right, let's take a look at a new problem. All right, use an identity to solve. Let's copy the problem here. Sine x cosine x is equal to 1/2. I have a double angle formula for sine of 2 theta. It's 2 sine cosine. Hey, I got an idea. What if I multiply both sides by 2? That would be 2 sine x cosine x is equal to twice 1/2, which is 1. And I also know that this is equivalent to sine of 2x is a double angle identity, okay? And that's equal to 1. And we could just do like we did before, okay? Sine of a equals 1. So a is going to be pi over 2. But hold the phone here. That was really 2x is equal to pi over 2. So you're going to, let's just do that over here, okay? Pi over 2, remember, plus 2 pi n. Let's divide by 2. Pi over 4 plus pi n. Okay, let's do n is equal to 0. What's our first value? Pi over 4. Okay, very good. That's neat. Okay, n is equal to 1. Well, can we make that pi 4 pi over 4? Makes it a little easier to work with. That'd be 5 pi over 4. Okay, n is equal to 2. That would be another 4 pi. So it would be 9 pi over 4. 9 pi over 4. But wait a minute, isn't that over 2 pi? Yes, that is greater than 2 pi. So we're going to stop that. And there are answers to that problem. Okay, so you got to be a little creative on that one. All right, now we're going to get sort of fancy. Question is sine of x minus cosine x is equal to 1. Well, this looks like a conjugate. If I multiply both sides by sine x plus cosine x, what would happen? Well, what would happen? I think I would have a problem. That's what would happen. What if I squared both sides? If I square both sides here, I would have sine x minus cosine x squared is equal to 1 squared. Now what's this going to give us? This is going to give us sine squared x minus 2 sine x cosine x plus cosine squared x is equal to 1. Now, hey, I see something here. Sine squared and cosine squared is 1, right? It is 1. So I have a minus 2 sine x cosine x plus 1 equals 1. Of course, we subtract the 1s, we get 0. So minus 2 sine x cosine x is equal to 0. Divide by 2. Divide by negative 1. Sine x cosine x is equal to, I'm sorry, divide by negative 1. That's equal to 0. And we know that is sine of 2x, double angle. And that's 0 at 0 degrees and pi. Okay? All right, that was a little tricky. Now, what I want to do is take a moment with this problem to explain a little bit about how to use your calculator. The problem really is right here. Can you solve that identity? Can you solve that identity? Well, you may remember we did solve that identity a little while back. But watch this. I'm going to put that in my calculator. Okay. I'm going to make y1 this guy, and I'm going to make y2 that guy. I'm going to use my x values here, my range values right here, and I'm going to graph it on the calculator. So here is that graphed on the calculator. Notice that I have my line y equals 1/2 right here, okay, right? Okay, and then I have my function, that other part, the sine, okay, going right here. Now the question is, where do they touch at? Here and here, okay? And those values are pi of a 4 and 5 pi of a 4. So yes, you can use your calculator to solve a trig equation, okay? So please keep that in mind. All right, last problem. Solve each equation correct to 4 decimal places. Well, we already know how to do this, but we're going to do it anyway. Tangent of x is equal to 12.8044. Now remember, tangent is positive here and here, okay? Now let's find that angle. Now this angle is going to be in radians, okay? So we're going to take our calculator and do, right, we're going to do inverse tan of the number, 12.8044. Okay, all right, so let's do that. Okay, so I did that on the calculator, and I have 1.492856. Well, we want to do that to 4 decimal places. 1, 2, 3, 4. So 1.4929. Okay, now remember, that is this angle right here in radians. That's one answer. Now, in order to find this angle right here, we realize that we're going to have to add that value to pi. Okay, so we're going to take our calculator and we're going to take this 1.49 value, 1.4929 plus pi. We'll just use pi on our calculator. And here we have 4.6900. Actually 01. Okay, so there are 2 values for the tangent. Now we're going to do the same thing with the cosine, but please keep in mind that our cosine is going to be negative here and here. So if I take my calculator and I do inverse cosine of negative 4317, okay, I'm going to get 2.0172. Oops, I ran out of room here. 2, okay? So that does make sense. That's over here, okay? So one answer is 2.0172. Now, we're going to have to figure out what that value is over here. And the way we do that is we take our number, here's pi, right? Okay? We got to figure out what this angle is right here, right? Okay? Subtract 3.14 or pi minus 2.0172, and I'm going to get 1.1243. Now I'm going to have to add that to pi to find this big angle here. So plus pi, and that's going to be 4.2660. Okay, so one answer was this guy, and the other answer was this guy. All right, so I do hope that working these problems, oh, by the way, I want to share this with you. You could even use a quadratic formula. Here's a quadratic using a trigonometry, and I'm going to try to figure out the values of sine that would cause it to work. So I use my quadratic formula, and I get that value, which is equivalent to 1.6. Remember, sine can't be over 1, so that wouldn't work. And then here I have my other possible value of sine, and that can work. And remember, that's in radians, and sine is negative here and here. And so I work my magic here, and I get this number, and then I get this number. Okay, so that's kind of interesting. All right, so that's all for lesson 5.5. I do hope this video helps you understand more about how to do the problems, because you could, rewind it and relook at the problem being done. Thank you.